Imagine opening a machine and finding a metal part inside that doesn't just rotate, it moves like a living creature. A part that twists, bends, reacts, and almost looks like it's breathing. Today, you're going to see a side of engineering that feels less mechanical and more biological. Because inside a gearbox, hidden away from the eyes of most people, there is a single component whose movement is so strange, so fluid, and so alive, you'll never look at machines the same way again. If you've ever wondered how gearboxes manage to transmit massive power so smoothly, the secret often lies in this one flexible part. It doesn't look dangerous, it doesn't look powerful, but when it comes to saving an engine from destruction, this creature-like component becomes the hero every time. Some mechanics call it the dancing heart of the system. Others call it the gearbox shock absorber. But today, you'll learn exactly what it is, and why it moves the way it does. Inside every powerful machine, motorcycles, cars, industrial motors, there is a moment when the engine produces more force than the gears can instantly handle. If that force hits the gearbox directly, metal teeth would snap, shafts would break, and the whole system would collapse. That's where this flexible part comes in. As soon as power enters the gearbox, this component bends and twists, absorbing the shock like a muscle taking impact. Instead of breaking, it stretches. Instead of resisting, it adapts. And instead of failing, it protects the entire machine. When you slow down its movement in ultra-slow motion, that's when the magic truly appears. You see the metal wobble like gelatin. You see the circular shape distort like rubber. You see it twist like an organism responding to pressure. It's almost unbelievable that something made of solid steel can move this smoothly. Engineers design this flexibility on purpose. The idea is simple: a little movement prevents a big disaster. This design philosophy is called flexible coupling, and it is one of the most brilliant engineering ideas ever created. The part is usually hidden deep inside the gearbox, so most people will never see it. But its job is critical. When the rider suddenly accelerates, it absorbs the torque spike. When the vehicle hits a bump, it prevents shock from traveling into the gears. When a gear engages too fast, it softens the impact. Every move you make, every twist of the throttle, every shift of the gear, this flexible part reacts instantly, like a muscle reflex. It keeps the machine alive. Many people assume machines are rigid, stiff, and purely mechanical. But engineers know the truth: mechanical systems often need parts that move like living tissue. Because machines don't fail from constant pressure, they fail from sudden shocks. That's why even the hardest metal is allowed to bend in the right place. This bending motion is not a defect, it is a feature. Without it, gearboxes would last only a fraction of their lifespan. To understand why this motion looks so alive, imagine holding a spring between your fingers. If you twist it, it doesn't break, it adjusts. Now imagine that same principle, but on a heavier, more compact, more precisely engineered level. The flexible part inside a gearbox behaves like a metallic spring plate. It is designed to deform slightly, then return to its original shape. This controlled flexibility is what gives gearboxes their smoothness, strength, and reliability. In some gearboxes, the part looks like a circular plate with cutouts. In others, it's a set of rubber-lined dampers or a spider-shaped piece. But they all serve the same purpose: to absorb shock. When engineers test these parts in high-speed cameras, the footage looks unreal. The plate ripples as if air is flowing through it. The rubber inserts compress like soft flesh. The entire assembly pulses like something alive. What you're really seeing is physics in motion. Torque enters one side. The flexible part reacts by twisting. As it twists, it absorbs excess force. Once that force stabilizes, the part springs back, transferring smooth power to the next gear. This behavior is essential for preventing damage. Without it, even the strongest gearbox would crack under stress. This is the beauty of mechanical design. Something as simple as a flexible plate can make the difference between a smooth ride and a broken machine. It proves that engineering isn't just about strength, it's about smart movement. It's about knowing where to allow flexibility and where to demand rigidity. It's about creating parts that behave less like metal and more like muscles. Because once you witness it, you'll never look at a gearbox the same way again. Please don't forget subscribe my channel thankfully.